the mathematical process we need to take in order to relate energy, frequency, and wavelength for electromagnetic radiation. So the two formulas we're going to be using are the speed of light equals your wavelength times your frequency, and then also energy equals Planck's constant times your frequency. Keep in mind, unit-wise, your wavelength has to be in meters. Your frequency needs to be in seconds to the -1 or hertz. Okay? And your energy is going to be in joules. C is your speed of light, which is 3.00 times 10 to the 8th, and its units are meters per second. Okay? And Planck's constant is 6.626. And the units for this are joules times seconds. Okay, so let's just jump in and do a problem. So here it says, what is the frequency of photons with an energy of 1? So I know my energy, it is given to me, and I'm trying to find my frequency. So I'm just going to plug it in. 1.4 times 10 to the -21st. That's in joules. Planck's constant is 6.626 times 10 to the -34th. And I'm trying to solve for my frequency. Okay? So what I'm going to do is I'm going to divide both sides by Planck's constant. Okay? Make sure when you're dividing in your calculator to put Planck's constant in parentheses. So now I can solve for my frequency. And the value that I get unrounded is 2.112, let's say 9 times 10 to the 12th. Keep in mind, I want to have, let's figure out how many sig figs. Well, 1.4 has 2 sig figs. 6.626 has 4 sig figs. So I want 2 significant figures. So this is going to be 2.1 times 10 to the 12th. And my units for frequency are going to be seconds to the -1 or hertz. Let's look at the next problem. UV radiation has a frequency of 6.8 times 10 to the 12th kilohertz. What is the energy in joules of the photon? Well, again, I can use my energy equals Planck's constant times frequency, because I'm given frequency and asked to solve for energy. However, there's one complicating factor here, and it's the fact that 6.8 times 10 to the 12th, your frequency, is given to you in kilohertz. So what I need to do first is I need to get kilohertz on the bottom, and I'm going to put hertz up top. Remember, 1 kilohertz is 10 to the 3rd hertz. So when you solve this, you get 6.8 times 10. Remember, 10 to the 12th times 10 to the 3rd, you add your exponents, so 10 to the 15th hertz. Okay. Now I can plug into my formula because my energy equals Planck's constant. And now my frequency is in hertz, which it needs to be. Okay. So now I can just multiply my frequency by Planck's constant. And the unrounded value that I get is 4.5, let's say 06, times 10 to the -18. Now I need to round. Keep in mind, 6.8 has 2 sig figs. 6.626 has 4, so I'm going to want 2 significant figures. So this is going to round to 4.5 times 10 to the -18. And since it's energy, my units are going to be in joules. All right, let's look at the next problem. It says, what is the energy of a light that has a wavelength of 434 nanometers? Okay, well, in order to solve for energy, I need to use my formula with Planck's constant and frequency. Well, I don't know my frequency yet. So what that tells me is I first need to solve for my frequency by using my speed of light formula. So speed of light equals my wavelength times my frequency. Now, the only issue here, remember, is that your wavelength needs to be in meters. And right now, it is in nanometers. So the first step I need to take is convert my wavelength in nanometers into meters. So I'm going to put nanometers on bottom. I'm going to put meters up top. Okay. 1 nanometer is 10 to the negative 9th meters. Okay. And so what I get is 4.34 times 10 to the negative 7th meters. Now you can either do that on your calculator, or just as a quick side note, you can note that 434 is 4.34 times 10 to the second in scientific notation. And so when I multiply 10 to the second by 10 to the negative 9th, since I'm adding my exponents, it's going to be 2 plus negative 9, which gives me negative 7. Okay? So now I have my wavelength, which is great, but now I need to solve for my frequency. So I'm going to use this formula, and we're going to do that over there. So my speed of light is 3.00 times 10 to the 8th. I now know my wavelength in meters is 4.34 times 10 to the negative 7th. And I'm solving for my frequency. So what I'm going to do is I'm going to divide both sides by my wavelength. Remember to put your wavelength in parentheses when you do divide. So I'm going to take the speed of light, 3.00 times 10 to the 8th, and I'm going to divide by 4.34 times 10 to the negative 7th in parentheses. And what I end up getting, unrounded, is 6.9124, let's say, times 10 to the 14th. Okay, remember, I don't want to round yet because I'm not done, because it's asking for energy, not the frequency. So now that I know my frequency, I can take this formula, bring it down here. I'm going to solve for my energy. I know that my energy is Planck's constant, 6.626 times 10 to the negative 34th, times my frequency, which I just solved for. So my 6.9124 times 10 to the 14th. Okay? Keep in mind, what I would recommend doing, since you just solved for frequency in your calculator, keep it in there, and now just multiply by Planck's constant, 6.626 times 10 to the negative 34th, because that way you're not going to be over-rounding. So the value that I get unrounded is 4.580, let's say 2 times 10 to the negative 19. Let's figure out sig figs. So the values that I used, 434 has 1, 2, 3 sig figs. Okay. Another value that I used was my speed of light, 1, 2, 3 significant figures, and then my Planck's constant, 1, 2, 3, 4. So I want my final answer to have 3 sig figs, 1, 2, 3. Okay, so my final answer rounded to 3 sig figs is going to be 4.58 times 10 to the negative 19. And my units are going to be joules, because I'm solving a lot of steps, but very manageable.